Welcome to Tomorrow Unveiled, the show where we break down the biggest stories shaping our world, straight from the cutting edge of space and science. So here's what happened this week. NASA's biggest moon mission just got delayed again. Again. And at the exact same moment, SpaceX just hit a historic milestone that most people haven't even heard about. And these two stories? They're actually telling us something really important about how space exploration works in 2026. We're going to walk through all of it: the technical problems, the engineering challenges, the business implications, and what it all means for humanity's return to the moon. But first, let's talk about what went wrong with Artemis II. Now, helium might sound like a party balloon gas, but in a rocket, it's absolutely critical. It does two essential jobs. First, it purges the engines to keep them safe before ignition. Second, it pressurizes the fuel tanks, so propellant actually flows into the engines when they need to fire. Without proper helium flow, you don't have a launch. You have a problem. On February 21st, during what should have been a routine fueling test, NASA detected an interruption in the helium flow through the Space Launch System's upper stage. That's the Interim Cryogenic Propulsion Stage, or ICPS if you want the acronym. The system had worked perfectly in two dress rehearsals earlier that month. But this time, something was wrong. And here's the crucial part. This wasn't something they could troubleshoot from the launch pad. The issue was deep in the rocket's plumbing, buried in systems that required the engineers to get inside, access the problematic areas, and figure out exactly what broke. That meant one thing: the rocket had to go back. On February 25, 2026, NASA's Crawler Transporter 2, this massive vehicle originally built during the Apollo era, began the slow, careful journey of hauling the entire Artemis II stack back from Launch Pad 39B to the Vehicle Assembly Building. It's a 4-mile trip that takes up to 12 hours. The rocket moves at about 1 mile per hour because when you're moving 11 million pounds of rocket and launch platform, you don't rush. But here's where things get complicated. That rollback had immediate consequences. NASA had been targeting a March 6th launch. That date is now gone, completely off the table. The earliest Artemis II can now launch is April 1st, 2026. Think about what that means. The Artemis II crew, 4 astronauts who'd entered pre-launch quarantine, who'd been in final preparation mode, who were days away from their historic mission, they had to exit quarantine. They had to step back from the immediate launch readiness. Their training continues, their preparation continues, but the mission just slipped by a month. And that's not just an inconvenience. Launch windows for lunar missions aren't like catching a bus where another one comes in 20 minutes. The geometry of Earth and Moon orbits creates specific windows where a launch makes sense. Miss one window and you're waiting for the next orbital alignment. NASA has windows opening in March, April, May, but each one is only a few days wide. That's the constraint of orbital mechanics. Why? Because Artemis II isn't just launching toward the moon. It's launching toward a specific point in space where the crew will encounter the moon at the right moment for their flyby trajectory. Get the timing wrong, and the whole mission changes. So when NASA says April, they mean they'll try to launch sometime during April's window, not necessarily April 1st. But here's what matters. That helium issue cost NASA a month of real time. So what happens now? The Artemis II SLS is back in the Vehicle Assembly Building, this massive 52-story hangar that's basically a cathedral of rocket engineering. Inside, NASA's teams immediately got to work installing access platforms. They needed to get to the ICPS upper stage, specifically to the helium flow system that's causing the problem. It's detailed work, methodical. They're not just replacing a part and moving on. They're troubleshooting a system that's buried deep in the rocket's architecture. They need to understand what caused the interruption. Was it a blockage, a valve malfunction, a sensor issue? Each possibility has different fixes, different timelines, different implications. While they're working on the helium system, NASA's also taking the opportunity to do other maintenance. They're replacing batteries in the flight termination system, the safety system that can destroy the rocket if something goes catastrophically wrong during launch. They're replacing batteries in the upper stage. They're doing a complete retest of critical systems. This is actually standard procedure in rocket engineering. When you roll back, you don't just fix the one problem. You use the time to address everything that needs attention. It's like when your car goes into the shop for one repair. While it's there, the mechanic does the full inspection and handles anything else that's borderline. NASA's engineers are being methodical because they have to be. This is the first crewed Artemis mission. The stakes are 4 astronauts' lives. There's no rushing this. Hey, real quick, if you're finding this breakdown helpful, do me a favor and hit that subscribe button. And turn on notifications so you don't miss when we break down the next big space story. We're covering space and science every week, and I promise you'll want to catch these. Now, back to what's happening in space right now. Because the story gets even more interesting when you look at what's happening on the other side of the space industry. On February 25, 2026, the exact same day the SLS was beginning its journey back to the vehicle assembly building, SpaceX conducted a Falcon 9 launch that hit a remarkable milestone, the 500th Starlink satellite launched in 2026 alone. Think about that for a second. 500 satellites in just 2 months. To put that in perspective, SpaceX is now operating Starlink as a commercial constellation at a scale that would have been unimaginable just 5 years ago. They're launching dozens of rockets a year, keeping operations lean, costs low, and cadence high. Compare that to NASA's approach. One massive rocket, one crewed mission, meticulous preparation, months-long timelines. These aren't two competing systems doing the same thing. They're two fundamentally different approaches to space. NASA is building a heavy-lift vehicle designed to send humans to the moon. It's complex, powerful, and requires extensive validation. SpaceX is building a reusable rocket system designed to launch frequently, reliably, and cost-effectively. It's modular, it's tested through iteration, and it's already proven itself. Every Starlink launch tests the Falcon 9, generates operational data, and puts money in SpaceX's pocket. That revenue funds their bigger ambitions, everything from Starship development to their data center constellation plans. And here's what's wild. Those 500 satellites represent SpaceX's growth trajectory in real time. They're not planning to launch 500 satellites this year. They're already halfway through, and we're still in February. Starlink now has over 9 million active customers worldwide. The constellation is expanding faster than almost anyone predicted. And every single one of those satellites was lifted to orbit on a Falcon 9 that landed itself and was reflown. So here's what's actually wild about space in 2026. It's not one race anymore, it's an entire ecosystem. And NASA and SpaceX represent two completely different strategies within that ecosystem. For most of the space age, there was only one way to do things. You built a rocket, you launched it, you flew the mission, you retired the hardware. Expensive, time-consuming, unrepeatable. That's why lunar missions were so rare. You could only afford to do them when the stakes and the resources aligned perfectly. But SpaceX changed that equation. They proved you could build a rocket that lands itself, gets refurbished, and flies again. That changes everything about the economics. Suddenly, launching becomes iterative. You learn with each flight. You improve between launches. You find efficiencies. NASA's building Artemis with that old mindset, not because they're stubborn, but because the requirements are different. When you're sending humans to the moon, you can't iterate by actually flying missions. You have to test, validate, simulate, and prepare with extreme thoroughness. One mistake doesn't mean a lesson learned. It means astronauts in danger. So the Artemis II delay isn't a failure. It's the system working exactly as it should. The helium issue was caught during testing. The decision was made quickly. Roll the rocket back, fix the problem, retest, and ensure everything's perfect before flying humans. That's the right call, even if it costs a month. Meanwhile, SpaceX is launching 500 satellites because their system is designed for that kind of operational tempo. Different missions, different constraints, different philosophies. But here's the thing, both approaches matter. We need NASA's methodical approach to exploration and discovery. We need SpaceX's rapid iteration and cost efficiency for infrastructure and commercial services. They're not in competition. They're complementary. Now, let's talk about something that connects both of these stories, what we're actually using all this space access for. There's something almost magical about photographs taken from the International Space Station. Astronauts are roughly 250 miles above Earth, moving at about 17,500 miles per hour. And they're capturing images that take your breath away. In February 2026, as all this was happening with Artemis and Starlink, ISS astronauts captured something extraordinary. Star trails above Earth. When you're orbiting at that speed and you take a long exposure photograph, the stars appear to streak across the sky because the station is moving so fast. Meanwhile, city lights below glow like scattered jewels. It's art and science colliding. It's proof that being in space gives you perspective you simply can't get anywhere else. But here's what's important. These aren't just pretty pictures. They're data. NASA's Earth observation program uses satellites and instruments to monitor our planet constantly. They track weather patterns, measure ocean temperatures, monitor ice sheets, watch for volcanic activity, and document how forests and cities are changing. When a hurricane is forming, Earth observation satellites tell us exactly where it's going. When a wildfire breaks out, satellites help emergency responders understand its extent and movement. When scientists want to study how cities are growing or how coastlines are changing, they use satellite imagery collected over years and decades. That data feeds into climate science, disaster response, agricultural planning, and urban development. And you know what? A lot of that Earth observation capability exists because SpaceX made launching satellites cheaper and more accessible. Better sensors can fly more frequently. Better data gets collected. Better decisions get made. Let's zoom out, because what's actually happening in space right now is a fundamental reshaping of what's possible. For 50 years, from the beginning of the space age until roughly 2015, space exploration was expensive, slow, and exclusive. Only governments could afford it. Only superpowers could justify the cost. Missions took years to plan, billions to fund, and sometimes decades to complete. Then Falcon 9 changed that. Suddenly, you could launch frequently. Costs dropped, timelines compressed. SpaceX proved that you didn't need to be a government agency to operate in space at scale. Now we're in this weird, wonderful moment where multiple approaches coexist. NASA's still building the heavy lift vehicles that can send humans beyond low Earth orbit. That's Artemis, that's the path back to the moon. SpaceX is operating commercial constellations, flying crew for NASA, developing Starship, and planning Mars missions. Blue Origin is building New Glenn. Other companies are launching lunar landers. China is advancing its space program. India is proving that space exploration doesn't require massive budgets. The Artemis II delay is frustrating, absolutely. But it's also a reminder that space is hard, really hard. When you're building a system to send humans to the moon, you don't cut corners. You find the problems, you fix them, you validate everything, and you accept that timelines slip. Meanwhile, SpaceX is hitting milestones like 500 satellites in 2 months. Because their system is optimized for different constraints. Both are succeeding, both matter. And here's what's really important. All of this space activity is feeding back into life on Earth. Better weather forecasting, better disaster response, better climate data, better communication networks through Starlink, better understanding of our own planet through Earth observation. We're not just reaching for space anymore. We're using space to understand and improve life here. So when Artemis II finally launches, and it will launch probably sometime in April, what exactly is going to happen? 4 astronauts will climb into the Orion spacecraft. The SLS will ignite, and 8.8 million pounds of thrust will push them beyond low Earth orbit. They'll fly around the moon, not landing on it, just flying around it, which is what makes this a flyby mission. They'll see the lunar surface up close in ways no human has seen it since 1972. They'll travel further from Earth than any human in 50 years. Then they'll return. The Orion heat shield, the largest of its kind ever built for a crewed spacecraft, will protect them as they slam back into Earth's atmosphere at 25,000 miles per hour. They'll splash down in the ocean. They'll be picked up by recovery teams. They'll have just completed humanity's first crewed deep space mission of a new era. It's historic. It's significant. And it's worth waiting for. The Artemis II delay isn't a setback for human spaceflight. It's evidence that the system is working. Engineers found a problem. NASA made the right call to fix it. The mission will be safer because of it. And while we wait for April, SpaceX will keep launching. Earth observation satellites will keep collecting data. The ISS will keep circling Earth, with humans aboard, conducting experiments and taking photographs that remind us how precious this planet is. That's the space landscape of 2026. It's complex, it's multifaceted, it's full of different approaches, different timelines, and different goals. and somehow it all works together. So here's what we've learned today. Artemis II hit a bump in the road, but that bump is telling us something important about how space exploration actually works in 2026. It's not one rocket, one mission, one approach. It's an ecosystem, NASA's methodical, human-focused exploration, SpaceX's rapid iteration, and commercial operations, Earth observation giving us better understanding of our world, all of it happening simultaneously. The delay is frustrating, sure, but it's also a sign of maturity in the system. We're not rushing to space anymore because we can afford to be careful. We're building infrastructure that's sustainable, reliable, and designed to last. And oh, if you're watching on your phone, there's a hype button right below the video. Tapping that really helps channels like ours get discovered by more people who love this stuff. Thanks for spending time with Tomorrow Unveiled today. Subscribe for more breakdowns of the stories that matter, the science, the space, the future. See you next time.
Let the future be